If you remember back from the previous videos, we talked about how John Dalton came up with the kinetic molecular theory of gases, and how he came up with 5 different what he called postulates or ideas about what gases should be. Now again, he claimed that these were for an ideal gas, a perfect gas, which we all agree there is no such thing as perfect. However, there are some gases that come really close to being ideal. So before we get into which gases are more or less ideal, let's talk about the things that make real versus ideal gases different. For one, if we're talking about a real gases have some attractive forces for each other. This can't be avoided because even van der Waals said no matter how small the particles were, everything with mass attracts everything else with mass to some degree, even if it's only something as simple as London forces. Whereas an ideal gas has absolutely no attractive forces at all. Again, there's no such thing as a perfect or ideal gas. Now, moving on, another thing that Dalton mentioned was that he believed that the individual particles of gases had no significant volume whatsoever. So an ideal gas would have no volume, but the truth is all gases, even the smallest, tiniest particles, even one single atom, would have some volume. However, if you're considering volume of a particle within a container, it is relatively accurate to say that the volume is so small it's negligible or you can ignore it. So, yeah, it's true there is no such thing as particles having no volume, but its volume is very small. And that's pretty much the only real difference between a real gas and ideal gas. Gases actually have some attractive forces, and actually their particles have some volume, where a perfect or ideal gas has no attractive forces or no volume. So what exactly would be classified as a more real gas versus a more ideal gas? Well, any heavy or large molecule would be considered more real than ideal. Gases also that show strong IMF or intermolecular forces would be considered more real. So for example, SO2 is not very ideal, it's more of a real gas. For one, it's relatively large in mass. It's a sulfur connected to 2 oxygens, and its molecular mass is somewhere around 64 grams per mole. It probably has a more significant volume than a tiny single atom or small molecule. Another very real gas versus ideal would be water vapor. Now, water vapor is not very large in size, but water vapor has hydrogen bonding. That's the strongest intermolecular force you can have. Not to mention SO2 also has dipole-dipole attraction. So again, these are not very ideal gases, they're more real. Now, what would be a more ideal gas? Something small, non-polar. That would be more ideal. Again, nothing's completely ideal, but it'd be closer to being ideal. So hydrogen gas, just H2, is not only nonpolar, but only weighs 2 grams per mole. Its volume is really negligible. And so is helium, a single atom. That's really small, also going to have no real intermolecular forces other than some small London forces. So those are more ideal. It's also good to mention that the smaller the gas is, according to Graham's law, the faster it's going to move. So these gases are not only more ideal, they're going to move faster, where these gases, like SO2, would move slower. And that is our flipped classroom on real versus ideal gases.